Your numbers aren't random. No, sit back down. Let's say that you have a nice gambling simulator, as everyone should. You then want to create a random number for the roulette, but calm the down. To get this, you use the standard rand function and set the srand or the seed to something and then assign an integer. Ooh, everything works. Time to run it again, as you like me have a gambling addiction. Bam! It's the same numbers. The numbers are the same because they aren't really random at all. Instead, they are generated by an algorithm to appear random, but in reality they aren't. But first, what actually is random? In common usage, randomness is the apparent or actual lack of definite pattern or predictability in information. A random sequence of events, symbols or steps often has no order and does not follow an pattern or combination. I wrote that myself, guys, trust me. But in short, an outcome being random is because we can't take in all the information about something and then tell what's going to happen. Let's say that I spin a wheel. To us, it is completely random, but if you were able to calculate the exact force produced by the spin, the wind resistance, the friction and everything else, we would know the outcome. When it comes to computers, we don't have anything random, as everything that happens is coded by us to happen that exact way. So we don't have to figure out the forces applied to the wheel, but we tell the computer what forces are acting on it. I mean, if I tell my program to print hello world, it doesn't print. Instead, we use algorithms where we tell the computer how to print seemingly random numbers. This algorithm varies depending on your version of C and C++, but the most common is this one, the linear congruential generator. As you see, it is so simple that even someone like, I don't know, freaking round earthers will get it. The random number is of course the number we are trying to generate, and next we have the previous number. This is the number that the algorithm generated before this time. But we don't have a number to start off with, and this is what the seed actually is. Since we don't have a previous iteration of the algorithm, we have to give a number to start with. The A, C and M parameters are all decided by the system and vary depending on what you use and what version. GCC often used 1103515245 for A and 12345 for C and 214748364 for M. Oh yeah, if you don't know what the percent symbol is, it is a modulo. It's kind of like division, but you know, not like division. We fit as many of the number on the right in the one on the left as possible, and then what is left is the result. So if we had 8 modulo 3, we can fit 2 3s in the 8, which means that we have 2 left. Also, if the number on the right is bigger than the one on the left, the result is just the number on the left. So now, let's say that we have the seed 5, A is 9 and C 6 and M is 4. We would then have 5 times 9, which is 45, plus 6 is 51, modulus 4 is 3. Now we take the result 3 times 9, 27, plus 6, 33, modulus 4 is 1. Now 1 times 9 plus 6 is 15. Modulus 4 is 3. You see, these pseudo-random numbers that are generated by the algorithms aren't infinite. The numbers will always repeat no matter what numbers you specify. This is because at some point the algorithm will result in the same value as the seed, which means that everything after will be the same as the start. This is known as a period, the length before the algorithm repeats. Depending on what numbers you choose, the period can be short or long. Or I mean, size doesn't really matter because... But why do we even use the modulo operator if it does all this? Why don't we just use something like division instead? One of the reasons is that modulo allows us to control how big the number is. The rand function will produce a pseudo-random number between 0 and rand max, which is a constant defined in the std.lib folder. And the modulo makes sure that the number produced is in between 0 and rand max. Let's say that we have the numbers 1 to 10 modulo 4. As you see, the highest number will be 3 and then it repeats. This is because if we had something that would have the result 4, we wouldn't, as another 4 could fit in and we would just have left 0. Therefore, the number generated can at most be 1 less than the modulo. Now we could do something like just have an algorithm with the number 0 to the max number, and the result would always be different. But first of all, this still has the max limit of the rand max before repeating. And second of all, it's not the best random sequence if a kindergartner can see the pattern. So maybe don't use the rand function for a casino simulator, or at least not one for me, because I live for the thrill. Now if you want actual random numbers, there are a lot of ways. As an example, you could use the Windows Crypto API to generate actual random numbers, or you could set up a camera in a public library, then use an AI recognition tool to count how many times specific people entered the library during the last week. Then multiply all those numbers and divide by the amount of girls that have erected you. Oh no, that won't work. You can't divide by 0. King shit.